So therefore the probability of each observation is 1 over n. So for x discrete, the population variance given by sigma square is sigma square equals sum of xi minus mu all squared times probability of xi, and if I write that down with the summation sign, that's x1 minus mu all squared times probability of x1 plus x2 minus mu squared times probability of x2 plus dot 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 plus mu squared n minus mu all squared times probability of xn. Now if all the events are equally likely, if all these events big X1 to big Xn are equally likely, it must mean we have something like this. Let's say X1, X2, these are the outcomes. So X and the probability of each of these outcomes, since they're all equally likely, and say we have, let's use big N of them, it must be 1 over n for each one. In other words, what you have here is a discrete uniform distribution, is what we could call this thing. Because discrete because there's a discrete number of outcomes, uniform because it's uniform probabilities, same probabilities for each observation. If we write that down, then you can see that this thing may be written as 1 over n sum of xi minus mu square, which then is the formula that some of you have seen all over the internet and wherever else. So what can we say? We can say then that this formula that you've seen is only applicable to the case where your outcome variable, your random variable, is discrete, but more also importantly that each of the outcomes are equally likely. When then might this be applicable? It might be applicable when you're doing a survey analysis and you've sampled the data using simple random sampling. So in that case, you've got a sampling frame and each person in that sampling frame is equally likely to be chosen for the survey. And that is a scenario when this thing then would be applicable. Hang on. Yeah, that example I've given you, if you've got the sampling frame and you interview absolutely everybody in there, then you can use this because this is the population variance. Actually, I don't like that example. I've just given you the random sampling. Just know that this formula is applicable when the outcomes, they are discrete, and also if they've got equal probabilities of happening. So this is something you can look out for on the internet or do on your reading wherever wherever you encounter it. So next time you see something where they give you a list of numbers like this, and then they ask you to compute the population variance, supposing this is from the population, you should ask yourself, well, are all these events, are all these things equally likely? If they are equally likely to occur, then you can use the formula that I wrote earlier, like this. But if they're not equally likely to occur, and this is discrete, you should be using the proper formula. This one. Okay, and it's because usually observations are not equally likely to occur, and that's why you learn about things such as the Poisson distribution, binomial distribution, normal distribution, all that kind of stuff. So on X this discrete, we have this, yeah. Then this little guy, the probabilities here, could be described by some distribution, as I said, like a binomial or a Poisson, and then that's why you've got to learn about all those kinds of various distributions. It's the same story for the mean, population mean. So if you're told that this is the formula, then this only holds if those observations are equally likely to occur and they are discrete and they are from the population. Otherwise, the general formula is this thing here, the expected value of x, which another notation for that is mu, and you know that the general formula for x discrete is the sum of x times px for discrete case, otherwise it's the integral of x over fx for continuous case, when x is a continuous random variable over the region of x. Okay, I don't want to make too much of a meal about it, so to take out of all this, basically just know that the proper formulas for the general formulas for the population variance is this thing, and for the population mean it's this thing I've written already above. Okay, hope that's been clarified, will help some stuff.